Well, howdy there, Internet students. Mr. Hermanson again. Hey, today we're going to start lesson 9.3 C. And what we're going to learn how to do mostly here is how to take something that's an expanded form and put it in factored form. So let's start by, and this lesson I'm going to split into two parts because there's quite a bit to it. So today's lesson, you'll just take notes and then finish up the problems that I suggest on the video, but you're not going to do a Google form assignment. Tomorrow you'll do the Google form assignment. All right? So anyway, remember that there's that factors are numbers that are multiplied together to equal something, and that factors come in pairs. So to get 24, you can have 1 and 24, 2 and 2 times 12, 3 times 8, or 4 times 6. Okay? And expressions also have factors. Like if you have 4n plus 8, that can also be written as 4 times quantity n plus 2. All right? When you're dealing with numbers, there's actually an expanded form for numbers also. Like 134 is 1 100, 3 tens or 30, and then 4 ones. That's what expanded form is. Okay? Well, when we're dealing with algebraic expressions, they also have an expanded form like that. Okay? And we're going to use the distributive property to expand and then also to factor, to put it in factored form. All right? Today we're going to just get really good at expanding, and then on the next day's lesson we will learn how to go backwards and go from expanded form to factored form. Okay? Now, one way that we can change it in an expanded form is we can just put the groups that mean what's in parentheses and then however many times there are, and add those up. So we have n 4 times here, that makes 4n, and we have 2 4 times, which makes 8. Okay? Now the other way that I like to do it is just to put the number you're multiplying by, the 4, outside the little box, and then at the top of the box put the n and the 2, and then just do like a multiplication table. So you get 4n here, 4 times 2 is 8, and these two parts make your 4n plus 8, your expanded form. Okay? Now, one thing you might want to do is check your expressions, make sure they are equivalent. In other words, they give the same result. So to check for n, to check that these are both equal for n equals 2, first way we're going to do it is we're going to take our 2, and this expression says add 2 first, which is 4, and then multiply by 4, which is 16. Okay, now this other expression here says multiply by 4 first. So starting with 2, you're going to multiply by 4 first. That gives you 8, and then you're going to add 8, and that gives you 16. So you can see we get the same result. Okay? Now, to show that it works for every value of n, all you have to do is expand it and show that you get the same thing. So one way to do it was, add n plus 2 up 4 times, draw a diagram like this to show that you have 8 there and 4n there. The other way is to use a diagram like this, or the distributive property to show that you get 4n plus 8 when you expand it. Okay? So, so what I'm going to do here is use my little multiplication table, area diagram, put the 5 on the outside, put the n and the 6 there to represent n plus 6, and then do the multiplication to show that I get 5n and 30. So this is true, okay? Where if I do it for this diagram, if I put 7 on the outside and an n and 3 here, this would be 7 times n here. 7 times 3 is 21. Whoops, that does not give us 7n plus 3, so I'm going to say false. Why don't you check the other ones here? So the only one that I found was false is number 6 here. Those are not equivalent. All right. Now we're gonna, so what we're gonna do to expand it, I'm gonna let you decide how you want to do it. I'll show you 2 ways, but one is to go ahead and make the area diagram. So I'm gonna put the 4 there and then split up the terms inside the parentheses at the top and then multiply them individually. 2 times 4 is 8, 4 times 3 is 12, and then write it out with an addition sign between them. The other way is just to multiply 4 times the first term, 2x, gives you this 8x, and then multiply 4 times the second term, 3, which gives you 12. So however you want to do that, go ahead and try the next 2. All right, notice how I was kind of lazy on this last one. 0.5 times 2 is 1x, but 1x is the same as x because 1 times any number is just the number. All right, here's where I'm going to do just a couple more with you, and you're going to finish them up, and that's going to be your assignment today. You do not have to submit your assignment. You just need to fill in your notes. But I'll do the front one on each of these. You'll do the other 2, and then tomorrow we'll finish up this lesson. So I'm going to suggest, well, you decide if you're comfortable not using this diagram, go ahead and do that. If you have a minus in there, make sure you put a minus in your diagram. So I'm going to do 3 times n, and then 3 times negative 4 is negative 12. And so 3n plus negative 12 is the same as 3n minus 12. All right, you're going to finish up those 5, but before you do that, let me give you some notes on these bottom 2. You can also just have a formula, and you can change the formula by expanding it in the same way. It's just that when you multiply r times n, you just are going to get the term rn. Notice I didn't put a multiplication sign in there because we don't do that with algebra. And then I'm also going to do r times 1. Remember, I can just write that as r because 1 times r is just r. And then you're going to write your expression like this, rn plus r. I'd like to show you one other where you have an option of how you could write it. This second one here. So I'm going to put n on the outside. Now remember, you could also just multiply the n times the 2, which would be 2n, and then n times the 7, which would be 7n, and it would look like that. You could have also, since it's just a 2 plus 7, that's actually just 9, right? So it's actually, you could write that as 9 times n if you want to write it a little simpler, okay? And it comes out the same way if you write it this way, 2n and 7n. All right, so go ahead and finish those up. So finish up everything on this page, and then you can stop for today. And if you have any questions about anything, go ahead and message me. All right, good luck with that.